I'm Emily. I work at Google. I work on open source integrations for Google Cloud.
Hi everyone, I'm Jesse Endahl. I'm the CPO and CSO at Fleetsmith.
And our talk is about authenticating to Vault with Google Platform and Fleetsmith. So just before we begin, how many of you know what Vault is and have used it? Cool, awesome, like a lot of you. So if you haven't heard, Vault is a tool for managing secrets. How are Google Cloud users using Vault? There are two primary use cases. We have secret management, and that's the most common case. These are for like customer stories, like a web hosting company is trying to save their database credentials in a much more secure way. They're currently being kept as plain text on their servers. Or a media company would like an easy way to manage their API keys, which are being stored as environment variables. There are a lot of secrets that you can store other than that, but developers want something similar to manage than a mix of like all these environment variables, source code, deployment managers, etc. A less common use case.
The screen behind you is not.
Oh, that makes more sense. Yeah. Sweet. Cool. A less common use case we see is an internal public key infrastructure, or PKI for service-to-service auth. We're seeing this a little more as more companies enter into like the microservice world and start to think about security in their infrastructure. Google Cloud is doing a lot in this space right now, and we most recently announced the Istio project, which is a service mesh allowing for authentication and encrypted communication between services. We'll be focusing more on the secret management use case in this talk, but the setup would also work for PKI. So we'll talk a little bit about how to use HashiCorp Vault on Google Cloud. So what a typical deployment look like before, usually start up a server, a HashiCorp Vault server in Compute Engine or GKE sometimes. It's more commonly in Compute. You have an authentication backend, which is how people obtain tokens to talk to Vault, and how secrets in Vault are ACL'd. And so most commonly we saw people using like a username or password that they generated on Vault. And so that's a separate identity from anything in GCP. Once you authenticate, then you get access to secrets. So secret backends are essentially any sort of third-party way to generate secrets or store secrets. So the most common one is just a generic one where you can store arbitrary secrets. And that's what most people are using. Another feature in Vault is a storage configuration backend. So this essentially allows you to use any sort of storage to long-term store your secrets encrypted. So they're the Google Cloud Storage backend, but it's community contributed and it doesn't support high availability currently, so we're not actually seeing a lot of people use it. But there are a lot of HA storage options available, like etcd, Zookeeper, or Consul. And finally, we have audit backends, which are, it's one of the benefits of Vault is that everything is centralized, and so you have a very good audit story where you can track all of the accesses to secrets in Vault. And so commonly, most of the Google Cloud users are simply just using the syslog audit backend and then storing their logs in Google Cloud Storage, but they're not really integrating it with the rest of their logging pipeline. And another non-backend feature is a lot of people have to worry about their unsealed keys. So when you start up a server, you have to unseal the Vault before it can be used by anyone. And this tends to be an issue because you need a set of keys. It's default 3 out of 5 unsealed keys, I think, to unseal a Vault. And this is usually done manually, and someone else has the keys set up in a separate password manager, which leads us to our next point, which is pain points. So there are a couple of pain points that we've run into. The first one being authentication options. So users end up having to create new identities, like we mentioned, with username and password. for their GCP entities within Vault. So we got a lot of questions like, can we just use our GCP credentials to authenticate to Vault? There's no native way to use cloud identities to authenticate in Vault up until a couple weeks ago, which is what I've been working on. So we released a new GCP auth backend with 2 brand new methods for authenticating GCP entities in Vault. So that's gone. And so I'll be talking a little about that more in depth later on. Some other pain points are unsealed key management. So to unseal Vault, as we mentioned, you need a certain set of keys, and that's used to bootstrap the entire system. So where do you manage those? A lot of people end up using separate password managers, which completely defeats the purpose of having Vault. So it's sort of like, do you really want to have more than one way to store your secrets? Another pain point is it's all self-managed. So Vault is not a natively hosted app in cloud, and you still need to run the service by yourself, so you still need to manage it, and if it goes down, you need to bring it back up yourself. Finally, we have issues with permission models. So in a GCP setup, you would have both cloud IAM permissions and Vault permissions to manage, and so how do you really do that? Source of truth is not really an easy issue to fix, but a tentative recommendation that we would say is to use Vault roles to ACL everything, and then use service account identities as identities. The reason being that within Vault, you have access to a bunch of other secrets, for example, multi-cloud credentials or things like that, and so by using that and giving out permissions as you need them, rather than saying, oh, this IAM service account has this permission, and now it has this one, but we forgot the other one. So now it has access to more permissions than it needs. Cool. So other things to consider when you're running Vault in GCP, are you doing multi-cloud or hybrid? Where do you have sources of truth then? And how do you do failovers? Are you using the same Vault for secret management and PKI? Are you having different services for each? Each service has its own Vault server and has its own secrets. Some people actually are doing multiple Vault instances, which is maybe unadvisable, but it's less common, but we have seen people use it. Overall, this sort of gets at where do you want the root of trust in your secrets to be? We'll focus on the use case where you're all in GCP and you're running a single Vault shared by all of your applications. So we've been working a lot to make this better, and so now we can talk about a best practice deployment for GCP. So as of this week, we've published a solutions guide. It's actually by Dan Isler, who's in the audience. He's a solution architect at Google, and so shout out to him for doing this great blog post. So as a brief overview, we'll go over how that works, but we'll also link to that at the end so you can go look at it. So at a high level, you spin up your Vault servers on GCE. You authenticate to Vault using the new GCP auth backend, which is what I've been working on, so I'm very pleased with that. You have a syslog audit backend, and you store the logs in cloud storage, and you integrate that with Stackdriver, along with your other logs. And you can use Google Cloud Storage as a storage backend along with other HA storage backends. And finally, you can wrap your unsealed key with a key from CloudKMS for safekeeping. We'll jump around a bit. I'm going to save the auth backend for last because I worked on it, and therefore I know the most about it, and I want to talk about it a lot more. First things first, as we mentioned, we started the server in GCE or possibly GKE. The unsealed key is kind of a hard problem since it is a bootstrapping secret. Customers choose a lot of different options, but we recommend that you store it in GCS or cloud storage encrypted with CloudKMS. For storage backends, we still haven't quite solved this problem. The downside of the GCS backend is that it's not currently available in HA, but you might want to consider actually using it in conjunction with other HA storage backends, because you can always use more than one. For logging, the syslog logs are actually very easily passed into Stackdriver. You can use Google Stackdriver logging agents, pretty out of the box. And so that's what we would recommend. And finally, the auth backend. So we've released this backend with 2 authentication methods. So the first one came out a couple weeks ago, and it allows you to authenticate to Vault using a self-signed or system-signed IAM service account JOT, or JSON Web Token. The second one allows you to authenticate Google Compute Engine instances using what's called an instance identity metadata JOT to authenticate to Vault. And so that feature was in beta, but it's actually being launched today, I think so, yeah. Yeah, they were originally supposed to do end of month, but they're like, hey, it's out, so go play. In both cases, you're having GCP sign something to provide identity to Vault. So as a reminder, we've written about this solution in a solutions doc, which is available on Google Cloud Platform, and we'll share the link at the end. But now we're going to dig deeper into the auth backend. A quick overview of the auth backend if you haven't really worked with auth backends in Vault. So we use the concept of a Vault role, which binds a policy or whatever secrets you can access when you have an auth token to authorization restrictions. So in the case of IAM, this would just be IAM role has a certain number of service accounts that can log in as that role. For GCE roles, we restrict them by what instance group that instance is in, zone or region, GCP labels, and other things like that. And so users will log in using a signed token, as we mentioned, specific to their entity. So IAM service accounts will have a service account key signed JOT, and GCE is an identity instance metadata token. So we'll talk a little bit about each of these in a little more depth. So how it works. This was the first one, and it came out a couple weeks ago, so I don't know if any of you have had a chance to look at it. But essentially, what you would do is you would create a service account to act as your identity. This could either be you give the service account the ability to sign JOTs for itself, which is maybe not recommended depending on what you use the JOTs for, or you give another higher up admin account access to act as the service account and sign that JOT. Following the principle of least privilege, you can create a new custom IAM role that only has the IAM service account's signed JOT permission, and then assign it to the actor. And so depending on what credentials you want to use to sign the JOT, that's the actor you would use. So then you say, Google signed my JOT. You send some claims along, and Google will use a system-managed private key to sign the JOT. The reason why this is nice is because it's managed by Google, so it's rotated by Google. It never gets revealed to the public. And in general, it's a lot safer than just using your own credentials to assert identity. And so once Google has returned the signed JOT to you, you can just say to Vault, here's my token, I'm the service account. Vault will take that JOT, go back to Google, say, give me the service account key that you used to sign it, and gets the public cert and verifies that token. And if everything works out, then you've logged into Vault. Yeah, and we have a small demo. Let's see. Cool. So I have a couple of scripts that I wrote. I'm just going to run them in debug mode and then explain what I'm doing. So the first step you would kind of take before any of your users actually try to log into Vault is you set up the server. I've already started a server, but it's done nothing else. So I'm going to run a setup script. So this will just print out the steps I'm running. Sorry?
What do you mean by server? What server do you have?
The Vault server. So yeah. So you start up a Vault server, and you say, this is where I should store my secrets, essentially. And so this script will essentially go through the steps that you would just need to do to set up a Vault server with the GCP auth backend. So initially, I'm just setting some variables. So this is the service account I'm going to create, and the IAM role I'm going to write to Vault. So first thing first, you just need to enable the auth backend. So there you go. The second step is you write a role. So this one is just writing an IAM role. You can see the type IAM right here. You've got the project ID, which is my GCP project. You've got the bound service account, which is the service account I'm going to create for this purpose. And then that's all you really need. And so it's written the role. And I'm also going to write a role for Jesse to use later for a GCE demonstration. And so that's another type of role, as we mentioned. Yeah. And so finally, I'm going to write config. So this is, you give Vault a certain set of credentials to verify and to make calls to GCP to verify the JOTs. So this only requires really like read-only access. It needs to determine like, is this service account still running? Can I get the service account public key? And things like that. So once you've got it set up, then you would essentially run this script. Cool. So I'm going to just run through it here and then quickly go through it in the same way. So you can see I set up the variables. I create the service account. I then created a custom role and added a policy binding, which essentially just binds that role to the actor. In this case, the actor is me, my emilyyee@google.com account. This is probably not advisable, but since it's a demo, I don't really care. So we then generate the JOT claims. So there are 3 claims that you, at minimum, need. The first is the audience, which is just in a JOT, saying like this is where the token is supposed to go. Usually this is a URI, but in Vault, it doesn't really understand what that is. So we just have it be Vault and then the role you're trying to log in as. It's not a required claim, so we just kind of YOLO'd it. The next one is expiration. So because this is a self-signed JOT, technically, we want to enforce a shorter expiration just so that the JOT can be treated like it's only being used once and not really being stolen. So the minimum right now is about 15 minutes, or the maximum, sorry. But you can configure that on the role. And then finally, the subject is the service account that you're trying to log in as. And so then you would call out to sign JOT in the IAM API. And then once you have that JOT, you would just log in. So I'm going to run that and kind of quickly run through it again. So writing all the variables, I created a service account. I create a role, and then I assign it. And then, so this is generating the expiration date for the JOT. Yeah, and then this is creating my OAuth token. And finally, I sign a JOT, and it will return the signed one right here. And so then I extract that. Unless, of course, my demo doesn't work. But at the very end there, you usually would just log in. So it might just be a permission thing. Yeah, but usually it works. Yeah, so at the very end, you would just say auth login as that. Yeah. So I think right now it's that I haven't logged in as the actor, and so it doesn't actually have the token, but the error message is a little off. I'm just gonna skip over that, but it should work. Cool. So going back to the presentation, we're just going to move on, I guess, to compute instances. So the second method would be, it just got added today. This allows compute instances to authenticate to Vault as well. And so this is how it works. So the GC instance has access to a metadata server without needing further permissions. So this can be accessed during startup. It requests identity token from the metadata server, and then the metadata server will return the signed JOT. And then GC passes this to Vault, which returns an auth response. I'm going to let Jesse demo this, so he can talk about how this works within his production infrastructure. But I'll talk a little more about like why you would want to use one over the other first. So IAM or GCE. IAM can be used by multiple resources, so you don't need a VM to run it within, whereas GCE only works within an instance. On the other hand, you don't need further permissions to allow a GCE instance to authenticate, where you would need either the service account or a separate actor to have permissions to sign a JOT. Or you would need to give it the credentials file and have it sign the JOT using that private key. I want to make it clear this is one auth backend. So why is that good? We had the concept of the two roles. So in this sense, a GC instance can actually log into an IAM role because it has access. The token is associated automatically with a service account. So you can just say, I want this to log in as if it were a service account. But it would still not require the signed JOT. Now I'll hand it off to Jesse to talk a little more about GCE and how they're using it at Fleetsmith.
Thank you. So just a quick reintroduction. My name is Jesse Endahl. I'm at Fleetsmith as the Chief Security Officer and Chief Product. Talking today about how we use the new GCE auth method to authenticate to Vault. Quick background on what Fleetsmith is, if you haven't heard of us. We do secure Mac management from the cloud, so things like patching, enforcement of things like disk encryption, as well as inventory. And as you might imagine, for something that's got control over laptops, we take security very seriously. So when we initially set out to build our infrastructure, we had a high bar for basically infrastructure security. And there was three things that we were really looking for. The first is just a general secret store. This is something that Vault obviously does very well. The second was we wanted to be able to secure our services, communication and authentication, including Vault itself with TLS certificates, as well as our Kubernetes cluster that we run on GCE. And then last but not least, for any type of customer-sensitive data, we wanted to be able to basically have crypto as a service so that we could encrypt it at rest. And Vault met all our needs here, and so we went ahead and moved forward with that. This is what our infrastructure looks like today. So we use Consul and as our storage backend, essentially. That's in an HA multi-region configuration. We snapshot all of our console state periodically and back that up to Google Cloud Storage for disaster recovery. We use three of the secrets backends, the generic, of course, the PKI for issuing certs, and then the transit backend for crypto as a service. We deploy all this, like I said, on GCE. We configure everything currently with Salt and Google Deployment Manager. We're looking at moving to Terraform, just haven't had the time. And then for the audit backend, we grab all of the syslog output and collect that with FileBeat and send it into our Elastic Stack cluster, formerly known as ELK. And then we store all of our unsealed keys encrypted at rest as well. So that is a quick overview of our infrastructure. Quick overview of the demo I'm about to give. So it's a simple 4-step process that you're going to see reflected in the script I'm going to run. So the first thing that happens is you have to make a request to the Google metadata server. You receive back some signed metadata. You extract a JWT from that. Then you pass that to Vault. And then what you get in return from Vault is the Vault authentication token. So pretty straightforward. So let's go ahead and jump in. Oops.
So sudo Sorry.
So we're just going to see the output of the script here. We're going to set a bunch of variables that we use throughout the script. So secrets directory, where we want the output, the Vault token to actually be stored. I suggest you make that a temporary mem disk of some sort, so you're not writing that to real storage. Set your Vault server address. Since we're running in dev mode, that's why you see just HTTP localhost there. Set your Vault server URL, your Vault role. It's worth pointing out here with the Vault role that we've hard-coded this for the demo, but in a real-world deployment, you would want this to be some type of dynamic information. So if you're using Salt, you could have your Vault roles mapped to Salt roles, or like GCE instance groups could be mapped to Vault roles. But that way you have some automated mechanism for your new instances that are coming up to know which secrets they should try to be fetching from Vault. Creating a temp file here. So this is really the beginning of the process that I just described. So the step 1, we're going and requesting a signed JWT from the metadata server. And we're going ahead and populating that into a variable that we're calling GCE token there. Now we're going to go ahead and use the signed JWT to request an auth token from the Vault server. So that's what you see there. Now we're extracting that token using JQ. Checking that it's a valid UUID there. Setting some aggressive permissions so that no one can read this token except for root in this case. And there we go. We've got the token, remove the temp file, and now we're going to go ahead and authenticate to Vault using that token. And there we go. This was the result back from Vault showing what that token is actually able to access. So that is the demo. Going back to the slides here, we had a few lessons learned from our use of Vault over the last roughly year. And there's really 2 learnings. One is that protecting, one of our goals, like I said at the start, was to protect Vault communications, console communications, Kubernetes cluster communications, all with TLS certificates issued from the Vault PKI. It, until today, was pretty cumbersome to actually bootstrap all that yourself. It's a lot easier now. So one of the things that the Google Cloud team actually released today is a Terraform module that automates all of that for you. So that's a really nice improvement. The second thing is just this problem that we're actually talking about today. How do you actually bootstrap that initial trust? You really need your cloud vendor to help solve that problem for you if you want it to be done in a secure manner. And so we're really excited and happy about the work that the Google team and Emily has done on this. It's pretty awesome. Back to you.
So that's our talk. Oh, is my mic not working? Oh no, it's good. You can always learn more. We have a bunch of blog posts about everything. And Dan's solution is the second link there.
Oh yeah, and we did a blog post as well on this, and specifically going more in depth into what I just described. We also included a little demo script, basically what you saw on the screen there, just as a kind of example starting point for people trying to do this in a real world scenario. So you can find that on our blog post.
Yeah. Just before we move to questions, I want to thank everyone who worked with me on this. Thanks to the HashiCorp people who reviewed all my CLs, or PRs, sorry. And thanks to the Graphite team who are here, so you should come bother them. It's Vincent, Dana, Joe, and me. Thanks to Maya, my PM, and thanks to Dan for writing the solution. And I think that's it. There are probably more people to thank, but.
Any questions?
Yeah. Oh, and thanks to Joe.